Okay. Okay, so today what we're doing is we're starting our new unit, which is lesson 12. So I'm just going to write lesson 12 here so you know what this goes with in our iReady book. What we're going to be doing is an intro to understanding systems of linear equations in two variables. So some of you have heard before what a system of equation is, and some of us haven't, which is totally fine. We're going to start with a definition, so we have an understanding of what systems means. So systems of equations, this is two or more equations with the same variables. So again, this is linear equations in two variables. We've been solving equations with variables on both sides. In this case, all of these equations are going to have variables y and x. So this is a little bit different. We're looking at something that's linear, and in the past, we've been looking at anything with two variables as a linear equation that we typically graph. So you are going to start out by learning about these systems through graphing, which we already know how to do. The solution to a system, if I was to graphic, so graphically, is the point x comma y where the two lines, and this is where they intersect. So where the two lines cross one another, that point is the solution to the system. If I was looking at this algebraically, which we will work towards learning how to do, the point x, y, those values are what makes both equations true. So we're looking for that true statement. And we'll go over algebraically later on. So right now we're focused on systems of equations and solving them graphically, which means we are back to graphing linear equations. Just like the equations we've been working on, anytime I have variables on both sides of the equal sign, I now have different types of solutions. So my first type of solution is if I have intersecting lines. Intersecting lines means that they crisscross. So imagine this is on a graph. Here's line 1, and this is line 2. And they are intersecting or crisscrossing. This point here is the solution. So anytime I have intersecting lines, I have one solution. That means there's one answer that makes this true, and it's written as an ordered pair, x comma y. Then over here, parallel lines. Parallel lines are two lines that go side by side, and they never intersect. So they look something like this. That's a little off, but you get the idea. Okay, so parallel lines are never intersecting. Therefore, they have no solution, no intersection. So we'll make a note here. Never intersect. Okay, so we're looking for two lines that are parallel with never intersecting. And then same line, meaning that I solved both equations, I graphed both equations, and when I graphed it, the lines ended up being on top of each other. So this would be same equations. Just like infinitely many solutions, when we are solving infinitely many solutions, we have both sides of the equal sign being matchies. They're looking the exact same. This ends up being the same line, so therefore it has to be the same equation, and then infinitely many solutions. Okay, so these are the three areas that are the types of solutions we can have. And what we're going to do is we're going to get into graphing and identifying solutions. Down here, solving by systems by graphing. So the first thing we want to do, so step number 1, is we're going to rewrite our equations rewrite the equation in slope-intercept form. If you recall, slope-intercept form is our y equals mx plus b. Okay. Friendly reminder, m is slope, b is my y-intercept. If you are not sure or we don't remember from what we've learned previously, I'm going to highly suggest you go back to your notes and you go ahead and take a look at graphing linear equations. And that would be a helpful place to start if you're not remembering what to do with this equation on the graph. So after we rewrite into slope-intercept form, the next thing we're going to do is we are going to graph the line, which is what we do normally. And then step 3, we're going to look at our graph and identify the solution or solutions, depending on the type of graph we end up having. So those are the 3 things we're going to do. When I come down here, solve each system of equation by graphing. So I'm going to graph. Looking at both of these are both written in y equals mx plus b. So there's nothing else I really need to do right now. I'm going to start on the top equation here. Before I graph it, I just want to point out that we have this here, this brace. This brace identifies it's a system. So all systems are written with a brace and then equations after it. So anytime we see that brace in our minds, we need to think this is a system because we need to do different things when that's the case. Okay, so graphing equation 1, y equals x minus 8. So y equals x minus 8. My slope is 1, and my y-intercept is negative 8. I'm going to start at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then my slope is 1. So I'm going to go up 1, over 1, up 1, over, and I'm going to repeat that a whole bunch of times so I can get a nice long line. And then I'm going to take my straight edge and I'm going to connect all these points, making sure that I extend through the points all the way, arrows at the end. It is important because we're looking at systems to make sure we're graphing the most precise line possible. So we want to add in lots of points to just make sure we know where that line's going. If the line is off even just a little bit, we may have a hard time identifying the actual solution to the problem. I'm going to go ahead and graph number 2 here. This is a y-intercept of 1, and then this is a negative 2. Now, I can go up and left. However, if I keep going up and left, I'm going in this direction. And when I'm going in this direction, I'm actually moving away from my first line. Since the solution here is the intersection, we need to move towards this line. So instead of going up and left, I'm going to go down 2, that's my negative 2, and to the right 1. I'm going to go down 2 and to the right 1. I'm going to go down 2 to the right 1. You'll see I just put that on the same mark that I previously had, down 2 to the right 1. I know that this is the point of intersection now before even putting my line because of counting out extra points on the graph. Extend it all the way through, arrows on the ends. Go back to the origin. This is 1, 2, 3, and down 1, 2, 3, 4, 5. So my solution here is 3, negative 5. And then if I wanted to check my work, I could substitute in. So if I have here y equals x minus 8, this is x comma y. I can substitute these in. So this would be negative 5 equals 3 minus 8. Negative 5 equals, that makes negative 5. That's a true statement. And then I can do the same thing to my second equation. And if it holds true, then that is indeed the solution to this system. Okay, going on to number 2 to graph. So coming over here, I'm going to graph my first one. My y-intercept is 9. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Plotting my point, and I have a slope of 1/2. Well, if I'm going up and to the right, I'm going to be off the graph before I know it. That's not going to be helpful to me. So I'm going to do a backward slope where I'm going to use 2 negatives in order to make a positive. So this is down 1 to the left 2. This is down 1 to the left 2. 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 Okay, so there's that line, and I'm going to go ahead and, well, those are my points. I'm going to connect my points to create the full line, making sure this is nice and straight and extending all the way through. Oh, that is not precise at all. We definitely want to make sure your line is precise as possible. Draw some arrows on there. Okay, there's my first one. I'm going to go ahead and now plot the second one. So this is 1, 2, 3, 4, 5, 6. And that is my y-intercept. And then my slope here is a -1. Again, I want to work my way towards this line because I really want to make sure that I figure out that intersection point. So that is going to be up 1 to the left 1, up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. When I did that, I drew the same point there. So I know that's my point of intersection. I'm going to finish off my graph by connecting these points, drawing arrows at the end. And then I need to identify where that point is. So this is 1, 2. So that's -2, comma, and that is 1, 2, 3, 4, 5, 6, 7, 8. 8. So -2, comma 8. And then like I showed over here, if you are worried about whether or not your graph was precise enough, you can substitute these values back into each equation here to make sure if it holds true. If it holds true, then you for sure know that you have the solution to the system. If it does not hold true, then you do not have the solution to the system. That in a nutshell is the introduction to graphing systems of equations and solution types. So you have all the information you need now to go on and finish this lesson. This is your notes, so I'm going to recommend that you fold this in half, glue it in your notebook, make sure you have it in a location you can refer back to in case you need to reference anything as we are solving. Okay, have a great day.